This week, my viewers' top choice for the most excruciating EDC gear review is Kunwu Django. Hi there, welcome to my No BS gear review channel. Kunwu is an up-and-coming, extremely popular knife brand, and Django is one of their top-selling models. This knife was sold to me in like-new condition by a gentleman who not only did not sharpen or alter it in any way, he didn't carry it more than once or twice. His word, not mine. And that is a mystery to me. Why would somebody spend that kind of money on this beautiful and, as you can see, extremely ergonomic knife and then not carry it? Well, you probably already saw a couple clues here and there, but let's deep dive into this knife and discover all the facts backed up by numbers. To help us along, I will be using this EDC board and this ED circle, where on the right you see all the human factors associated with EDC gear, and on the left all the performance parameters, all of which together form the essence of a knife and make it EDC worthy or not. Whether you're buying a knife in a store in person or based on some recommendation on some forum by some influencer online, the first thing you look at is the blade length. 3 3/16 of an inch in this case. It is also important to know how much of a cutting edge do you have on this blade. And again, it's 3 3/16. And this 1-to-1 ratio is great because this knife actually has a large finger choil at the base of the blade. How much does it weigh? On my channel, I measure and calculate cutting edge to weight ratio. I call it the edge penalty factor. It is how many inches of cutting edge you get for each ounce of weight. After all, the knife is a tool, and while flickability or acoustics and the looks are important to a lot of people, in the end, it's how well the knife cuts is what matters. And here I'm trying to determine how much of a useful edge will I have if I cut something on a cutting board. And it's 2 inches before my knuckle hits the board. And at about 2 inches, the useful cutting edge for this application is actually more than half the blade's length. That's an excellent result. It's a pocket knife, so how well it pockets is critical to whether or not you're going to carry it with you or leave it in a drawer somewhere. A typical jean pocket has a seam that is approximately 1/8 of an inch thick. My EDC is equipped with a pocket emulator, which is a webbing belt of the same thickness that allows me to measure forces required to insert and extract the knife. I find 2 to 4 pounds of force ideal, and this knife is 2 pounds outside that envelope. I guess the tighter pocket clip was required because at 4.4 ounces, this knife is kind of hefty. But the clip works well and retains the knife in the pocket. It is likely you notice that I am struggling with thumb opening this knife, and the reverse flick also requires a wrist movement or no go, which is a surprise because this knife is equipped with a large diameter multi-row bearings. I will be measuring the opening force, which will tell me how well the detent is functioning. So far, any access lock that I tried that opens well shows the force of 1.2 pounds or greater required to break the detent. In this case, we're right in that window, measuring 1.2 to 1.6 pounds of force. So why am I having so much trouble in this case? Is it overcompression of the bearings? Is it ergonomics? Write me a comment if you know what that is. Meanwhile, I'm moving on. What is a knife lock? It's a lock. A lock supposed to stay locked until you decide to unlock it. And my Hype Smasher machine is designed to test just that. I constructed this clamp to resemble human hand grip. It has steel pins covered by rubber hose, which emulate skeletal structure of your hand. I am making sure that the knife is not overcompressed and the lock remains operable even as it's clamped. The ram on this modified arbor press weighs 2.5 pounds. It accelerates over a distance of 6 inches to strike the blade with a force nearing 80 pounds. An overkill? Perhaps, but how come some knives stay absolutely solid and others unlocked? This one passes the first strike and the lock is still fully functional. 2 more and we are done. I can take a breath again. After all, I don't want to damage a knife that cost me over $200. Not to mention the fact that this DLC coated blade and a diamond textured handle combination are no longer available. And it's a pass. We can take the knife out and check functionality. Before I do, let me tell you this. If you struck this blade on the spine with that much force more than once in the real world, you should probably see a psychiatrist. Unless you're a knife reviewer, which in itself should be a diagnosable condition. The knife is fine. No side-to-side or vertical play. The function remains no more sluggish than it was before I tested it. Basically, it's a full and complete pass, although I will look for internal damage when I take it apart to examine the blade. For now, let's see how Kunwu performed sharpening. Let's put it under the microscope and start with the tip. That will tell us a lot about how professional is the person who sharpened it. And by the looks of it, the tip is in a great condition. Clearly the knife was stropped, but not excessively, so the tip didn't get rounded off, and there's only a little bit of convexity near the apex. I do notice that the width of the secondary bevel varies by a small amount, and that means that the edge angle is varying as well, perhaps by 1/4 of a degree. Next, we will look at the intersection between the primary bevel plunge line, sharpening choil, and the secondary bevel. And in this case, everything looks great. You will be able to resharpen this knife several dozen times. And honestly, I don't know if many people will use it to the extent where it requires so many sharpenings, but there's nothing in the design that precludes this knife from being a very hard-working tool. That said, I always recommend resharpening the knife if you're going to carry it, because, you know, mistakes happen in production. Sometimes the edge gets overheated, which negates the edge retention properties of even the best steels. So removing that quote-unquote burnt metal will get you to the perfectly treated steel. Do take a look at the finish. A near polished satin finish with DLC coating. Beautiful. This is my first knife with this finish, and I can now see why some reviewers and knife designers literally gorge on shiny DLC. You all know who I'm talking about. Take a closer look at this almost perfect tip, just a slight rounding off from stropping just a hair. This is L-Max, a steel that is designed to be easy to sharpen and strop when properly heat treated, and that is what we will check next with my leap tester. I will verify its calibration on this block that is certified to be at 787 points on the leap scale. Leap scale has an order of magnitude finer resolution than Rockwell C, and the average of 5 strikes comes out to 785 points. 1 point on leap scale equals 0.07 points on Rockwell scale, meaning we'll be adding 0.14 points to all our averages. The gel on the block ensures that there are not air pockets between the blade and the steel block, which would give us artificially lowered readings. Because leap style testers are sensitive to the thickness of the metal, I have to keep the blade on the block. I am not removing the coating because DLC is really more of a surface treatment rather than plating or coating. This process takes place after the heat treat and requires the blade to be reheated to high temperature again, leading to further softening of the steel, as if you were tempering it for a second or third time. Here comes the average, but I need to recalculate it for the zero shift correction, and it comes out to 57.9 HRC. A fresh dab of gel will ensure that I get accurate readings on the left side of the blade. The range of individual measurements on the right side were pretty consistent. There are no outliers. Outlier is a measurement that is clearly outside the range. Please don't forget to hit the like button while I'm resetting my meter here, or dare I ask, hit share and copy the link. You don't even have to send the link anywhere. Algorithm doesn't know that. It does know when you click it, and it sends it into frenzy. If you are not a subscriber already, please subscribe. This way, the other reviewers to whom you might already be subscribed know that you are watching an independent unaffiliated reviews on my channel, and perhaps adjust their practices and do a little more testing themselves. After removing one outlier and correcting for zero shift, I still get 57.9 HRC. On their website, Kunwu advertises 60 to 62 HRC for an uncoated blade. And this knife is 2 points under. So how would this steel perform at this hardness? Let's find out using this 50 Newton trigger gauge and some fishing line loops that I meticulously made out of this line. That's the fine 4-pound line I got from Walmart. The reason I settled on using the fishing line is because it's rated both for breaking force and elongation. It does resemble tests conducted with this device on the screen, but the differences are this is a straight pull versus a leveraged cut, so there isn't much correlation between the two devices. This test merely shows how sharp it was before and how dull it is after what I'm about to do next. And then I will report out the percentage of edge sharpness reduction. While this is not a codified method for sharpness testing, or edge retention testing, I do get pretty consistent results from test to test. And that is because I take more than one measurement. I usually make 3 to 4 cuts and then dispose of an outlier, which does happen, as you just saw, and calculate the average afterwards. Where was I? I think it was a third measurement, so I'm going to take one more to be certain that my average is statistically significant. Yeah, as you could see, it was pretty consistent, and I end up with 372 gram average. I use buckhorn for the next step, which tests the blade in 2 different ways. The hard carbons in the structure of the horn test the wear resistance, and the horn kind of grips the edge, so it simultaneously tests its ability to resist rolling. And I do 20 back and forth strokes on all the blades that I test. Back to measuring the sharpness with the fishing line loops. In the charts, this steel is rated higher in edge retention than crew wear, but those charts show the steel at 61 HRC or higher, which is not the case here. That's surprising because amongst the knife enthusiasts, Kunwu is viewed as one of those companies that does great heat treat. Yet I haven't found a lot of videos or information online about the actual independent tests. Anyway, I have an uncoated Kunwu LMAX blade in my possession, and perhaps I'll test it pretty soon. But right now I'm focused on crossbar lock knives, and I'll do the other Kunwu when I get to the frame locks. I'm talking about Zen Compact. I also have S-Tao of a generation that came with a titanium clip. The steel is Vanax on that one. And from Kunwu's budget line called Ironfly, I have the Superfly model, which is a large liner lock and 14C28N steel. Let me know in the comments if you would like to see any of these knives on my channel. I got 47% sharpness reduction. And the picture just saw Praetorian T was there for the size comparison, although I can review that one as well. Just let me know. I saved the most nerve-wracking test for last. This is toughness or strain resistance test. 1/4 of an inch of this blade is secured inside the oak vise. I pull on the handle until the blade reaches 15 degrees on the carpenter's compass. If there is disbalance between the blade's geometry and its heat treat, the tip will break off or become permanently bent. Next, while the blade is still in the vise, I will apply torsional loads in XY plane to see if the knife has durability as a system. The torque I'm applying exerts pressure on every component in this knife. Let's see how it did. No permanent deformation. Let's double check. I don't see any, do you? The mechanism still works. Checking for play. There is zero play in any direction, which is a surprise because the knife's construction is as complex as I've ever seen. The parts count as 27, which must be some kind of record. Plus, they threw in lightweight backspacers and a wire pocket clip. The coup d'etat, the piece de resistance, is the 7-part crossbar. All that is so that I can have an oblong-shaped knobs? I mean, what the heck? 7 parts, and that's not counting the springs. Knobs with screws. So, how did Django do? At over 4 ounces, 0 points for weight savings, 1 solid point for blade length being equal to the cutting edge length, and the cutting edge to weight ratio is 0.72, so 1.72. 1 point for being able to put it into the pocket and take it out without modifying the clip or using 2 hands. While it seemingly should have 3 ways to deploy the blade, only 2 of them worked comfortably, pulling back on the crossbar or reverse flicking. So it adds on 2 points, but no extra credit for being snappy, for it is not. Which, in my opinion, detracts from the feeling of owning a premium knife. I heard through the grapevine that Kunwu made some adjustments with Django springs, but the one I tested did not impress me in the blade deployment department. And yet the lock itself performed great. It locked in place, even the Hype Smasher wasn't able to budge it, and it unlocked easily without lock stick of any kind. Plus, it's one of the most finger-safe locks in the market, so 3 points well earned. The blade steel gets 1 point for being highly formulated alloy, complex premium steel for sure, and a 2nd point for being a powdered steel. Unfortunately, it's not heat treated into its perfect range, so it misses out on that point. 2 points for steel, I think, is a fair score. Now let's talk about durability. This knife performed amazingly well. Not only did it survive the Hype Smasher test without any damage to the internals whatsoever, 1 point for that, another point for not opening up a blade plate, and another point for surviving the blade bending test without losing a tip. The factory edge retained 53% of its sharpness even after my brutal buckhorn test. But 47% sharpness loss only gets it 1 point. The blade shape and overall knife geometry offers 2 inches, more than half of the blade's length for cutting on a cutting board. That's definitely a well-earned point. And the other 2 points are for having a rather slim behind-the-edge thickness of only 17 thousandths of an inch and flat grind almost to the spine of the blade. This is a slicing machine. So let's sum it all up. The overall EDC score for this knife is 15.72. Hallelujah! I finally finished reassembling Kunwu Django, and believe me, there's nothing trivial about that because of all the extra parts. But from like technical standpoint, it all made sense to me once I figured out how it all works, how all the components in this little pocket-sized system integrated with one another. And I have to say, when it went back together and I had to spend no effort whatsoever centering the blade or eliminating the blade play, that's when I tipped my imaginary hat off to the designers and said, hallelujah. 15.72. Is it a great score? It's a decent score. Anything above 15 on the ED circle will get a designation of EDC-worthy knife. Could the heat treat be better? Could the blade deployment be better? Yes. But, you know, to be honest with you, some of us, not all of us, but some of us will take that durability and reasonable edge retention over anything else. And I didn't see anything in like heat treat, nothing I couldn't figure out by changing the sharpening angle to improve the edge retention. And that's about all I have to say about that. Let me know in the comments if this review was everything that you expected or if there's anything I can do better. Again, please read the comments. I've been blessed, my channel has been blessed with some of the most knowledgeable, intelligent people in the knife community leaving comments and sharing their wisdoms with us. So read their comments or you will be missing out.